Hi, this is Ram Kumar and this is my final project demo for GAM475 course at DePaul. So this is my game engine. I'm just gonna quickly go through the features of my game engine. Here the game engine basically supports multiple viewports with multiple cameras. So here I have two viewports showing the same camera, so I can also switch the camera inside each viewport. So I'm going to select the second viewport and switch the camera inside it, and the first one, yep, there. So the viewports and cameras are managed by two different managers so that they can get assigned individually irrespective of the viewport region, and so they are completely decoupled, so could be reused everywhere. And if I want to bring one of the viewports to the full screen, I can do that just by pressing a button here. So this is viewport 1 in full screen, and this viewport 2 in full screen, and it displays the side camera which is on the x-axis. So going to the cameras, I have 4 cameras set up here. So this is my camera 2, and the one in green is my camera 1, which is looking through the z-axis, and my third camera is at the top looking through the y-axis, and my fourth camera is kind of inclined and looking at the center. So these are my cameras, and the wireframes are the camera frustums drawn inside here. I can hide them or unhide them by pressing escape. And here the cameras basically support all the basic movements like going forward, backward, right, left, and apart from these movements, it also supports moving up and down, and also the special mouse movements tilt and pan movements. These are mapped onto mouse, and this is quite easier to use them to move around the 3D world. And also the camera supports rotating about a point, so I've set up the rotation point as the origin right now, so I'm gonna rotate the camera for about that point, about the x-axis here. So this is about the y-axis, I'm sorry, z-axis, and the reverse here. So this is how my camera works. It supports all basic movements of any camera. And let's go to the frustum culling and see how it works. So for that I have to disable some of the objects here so that I can clearly show. So, okay. I'm just gonna display the pyramid for the frustum math here. So let the viewport 2 have camera 1 and viewport 1 have the top camera, and I'm gonna move the camera 1 from the viewport 2 so that you can see how the culling happens through the viewport 1. So I'm moving the camera to the right, and you can see the objects towards the left are disappearing slowly. So I'm gonna display the collision volumes here so that it'll be useful to understand. So once the collision volume moves out of the region, so the objects are hidden, which means they're not drawn, they're just skipped. So here I just displayed the collision volumes for demo purpose, but they're also gonna disappear. So let's look at camera 2, so that you can camera goes up, the objects at the bottom are disappearing, and here the objects at the top are disappearing slowly. And when we rotate, so it's looking at the object at the center. So when the frustum moves out of the regions, the objects that falls outside the frustum are not drawn here. Okay, this is how the frustum volume computation works in my engine. Let's take a look at the individual objects here. Here we have pyramids and cubes and spheres, as well as the taper boxes, which I call the spaceships here. And all these have different state information and like different transformation, different rotation, plus different light, different colors there. So all these are individually maintained by each object there. So each object has their own collision model. As I've shown before, I'm going to display the collision models around them. So they have their own collision volume, and the frustum culling happens with this. And this and texture information are stored inside each object. So these textures and shaders are switchable dynamically. So I'm going to show an example of how to switch the shaders for the pyramid object. I go to the camera 1, and right now I have texture with point lights shader mode for this, and I'm gonna switch the shaders for this one. So I'm gonna select this object. I can switch the shaders by object type, so I'm selecting pyramid object. So this is flat shaded, and this is texture with point lines again, and texture with no lights, and again the default one, the thicker wireframe, and the thinner one, and again it loops back in. And also it's possible to switch the texture for all the objects, I mean by types. So I'm going to switch the texture for the pyramid object types here. So for that I should have a texture shader. Just press of a key switches the shaders, sorry, the textures. Yeah, there you can see it dynamically switching the textures there. And this checker texture is the default one, and it gets picked whenever there are no textures applied on the object, but the shader mode requires a texture. So this is a default one that comes whenever it's required. And it's also possible to override the individual shader modes in the environment, and so that you can apply a single shader for all the objects in the 3D world. So I'd go to top camera for this. Okay, I'm going to switch this shader mode for all the objects in this. Okay, so all the objects are in wireframe mode now, and thinner one, and this is flat shaded one. And also I can override the individual light information here. This is taken care by the global light manager. So global light manager comes into play whenever the global light is set, and it just overrides the individual lighting information. So I'm going to enable the global lighting. So right now the global light active is in red color. So I'm going to switch the global light now. It's in blue, yellow, and it's white. All the displayable objects here are implemented from graphics object, which is implemented on PCS tree. So the graphics object mandates the derived classes to implement certain methods, and the move method is also one of them. So which means that movement controls are not just applicable to cameras, and they are applicable to individual objects too. So I'm gonna move the pyramid object right now, which is at the center, to forward. Sorry, that's backward. So this is forward, and out of the first one, backward, up, down, and left, right. So all these movements are relative to the world axis, so not relative to the individual local axis. So this dependent on the orientation of all the objects, because they don't have individual local axis. This is my framework startup call, and it creates each object one by one in the order. Initially it creates cameras and the viewports and loads the texture from file, and it creates lights which are used for global lighting, and after that it creates all the objects one by one. So here the textures are loaded directly from the TGA file, and they are assigned a unique name, and this is being referred in each object that's created here. So that's how they are picked, and for the models they are picked from the model file, which are stored under this folder, and once they're created, their VAO are loaded into memory, and they are referred in the subsequent pyramid object creations.